Let's look at this question on equations of linear relations. Determine the equation of the line that has the same x-intercept as 3x minus 4y plus 9 equals 0 and the same y-intercept as 2x minus 5y minus 10 equals 0. So just for a prior knowledge, I'm just going to draw a linear relation. So if we have an equation, a graph like this, that's going to be the y-intercept, and this is going to be the x-intercept. At the x-intercept, y would be 0. At the y-intercept, x would be 0. So we're going to be using these properties to solve this question. So determine the equation. So the first equation that's given is 3x minus 4y plus 9. So this new linear equation that we have to find has the same x-intercept as this linear equation. So we have to find the x-intercept of this equation. To do that, I'm going to be substituting 0 for y because I know at the x-intercept y is 0. So substituting y equals 0 into, I'm going to label this equation 1, into 1. So 3x minus 4, and for y, I'm substituting 0, plus 9 equals 0. I'm just going to have to isolate x because I'm trying to find what x is. 3x is equal to, so that would be 0, so that's gone. 9, when I move it to the other side, it's going to be negative 9. To isolate x, I'm going to have to divide both sides by 3. That's going to give me negative 3 for x. So we found the x-intercept of the new equation that we have to find. So that would be the x-intercept. Let's write that. So I have the x-intercept, which is negative 3. And from the other equation that's given in the equation, I'm going to find the y-intercept. Let's write the equation of the other linear relation. That's going to be that. Since the equation that we are trying to find has the same y-intercept as this relation, I'm going to be substituting x equals 0 into 2, equation 2, so that I can find what the y-intercept is. So I'm going to isolate what, this time I'm going to isolate y because I'm trying to find what y is. So that's negative 5y. I'm going to have to move all the other terms to the right side of the equation. So that's going to be negative 2x plus 10. Now when I substitute 0 for x, let's see what I get. Negative 5y equals negative 2, and then that's going to be 0, plus 10. And negative 5y equals, that's gone because that's going to go to 0, so that's going to be 10. Y is equal to isolate y, I'm going to have to divide both sides by negative 5. That's going to give me 10 divided by negative 5 is negative 2. So now I know the y-intercept and I know the x-intercept. The y-intercept is negative 2. Now I'm going to use these two pieces of information to find the equation of the line. So let's write the general form of the slope-intercept form, mx plus b. In this form, m is the slope and b is the y-intercept. So out of the two unknowns, we already know one of them, the y-intercept. We only have to find the slope. So using the y-intercept, we're going to be finding the slope of this equation. So let's do that. I'm going to write the x-intercept as coordinates. So to write x-intercept as coordinates, since negative 3, 0, so that's, I'm just writing that as coordinates for the x-intercept, is on the line. I'm going to be substituting that value, these two values, into the equation so that I can find what the slope is. So y is let's write the equation so that we know what we're working with. Mx plus, it's not plus, it's b. I have to replace the b with -2, so let's do -2. And for y and x, I'm going to be substituting these values. So y is going to be 0 because that's the x-intercept, and m, and that's going to be -3 minus 2. Let's solve for m, so that's going to be -3m minus 2 equals 0. I have to isolate m. So let's leave m on the left side and then move the -2 to the other side, which is going to be +2. Now to isolate m, I'm going to have to divide both sides by -3 or bring the -3 to the other side, which is going to be m equals 2 divided by -3. So I know the slope and I know the y-intercept. So now I'm ready to write the equation of the line, which is y equals -2/3x -2, because -2 is the y-intercept. So that would be the equation of the line with the x-intercept of the first relation and the y-intercept of the second relation.